Hi everyone, my name is Yugam Arora and today I am making this video to present our final presentation for the course Form 340 by Dr. Russell. So in this presentation, we would be covering topics from our textbook from 5 chapters. That is file types from chapter 4, device controllers from chapter 5, the ostrich algorithm from chapter 6, spyware from chapter 9, and history of Android from chapter 10. So these are the topics we would be covering. And so let's start with the chapter 4, file types. So first of all, what are files? Files are used for storing information like text, images, or any kind of data in any format. To store a file in the system, we have to specify the file name and file type. Ordinary file contains all the information created by the user. These are four main types of files. Directory files are the files which are stored in directory or folder. Special files are those files which are necessary for the system to run, and all of the files of the operating system can be referred to as special files. These files are stored in system using .sys extension normally. So there are two special files, two of the main special files, character special files and block special file. Character special are those files which are used to model input output by devices such as printers, terminals, etc. And the block special files are used to model disks. So talking about the ordinary files, there are either ASCII files or binary files. ASCII files can be viewed and displayed as is, but it's not the case with the binary files. Now the binary files are of two types: executable and archive. Executable consists of 5 sections, which are header with a header, and header contains a magic number to identify if it's an executable file or not. Then comes the text, then data, relocation bits, and symbol table. So this is a diagram of the executable file at the side. So, there was a one question I read. So does file type rely on file extension? Well, I would say file extension is mainly used so that the OS operating system can call the program appropriate for it to run. So Windows actually rely on file extension to know if it's an executable or not. But we should not rely on the file extension, as it is easy to create a header for some different extension, and it might be possible that the information inside the file is different. So like the information is different but the extension is different. So next we move on to device controllers, which is from the chapter 5. The device controller can be referred to as electronic component present in input and output units. It can be seen as a printed circuit board on PCIe slot, which can be found in laptops and PCs, all of the PCs. So generally, a lot of controllers have cable attached to them, which can be attached to device itself. So it acts like an interface. The companies make controllers that match the interface of the device. For example, companies like Western Digital, Seagate, they make disk drives with SATA, USB, Thunderbolt, etc. These are interfaces. So the device controller consists of a serial bit number, which have a preamble in the start. The 496 bits in the center in the sector, and there is an error correcting code in the end. So what happens is the device controllers and device driver, they're always there to communicate with the operating system. Both are necessary for the system to communicate in between. So a device controller may be able to handle multiple devices. As an interface, its main task is to convert the serial bit stream to block bytes, perform error correction as necessary. I got this reference from tutorial points. So the next I would like to talk about is ostrich algorithm. There's nothing additional information I can find here, but I tried my best to find the ostrich algorithm. So ostrich algorithm states that when the storm approaches, an ostrich puts his head in the sand and pretend that there is no problem, like nothing is going on. So this is probably the one of the easiest way to deal with the problem or with the deadlock, we can say. It basically asks to ignore the problem. Different people approach to this with different strategies. For example, if I go to mathematician or scientist, they find it unacceptable to have a problem, and they always try to resolve it, while the engineers take a practical approach to this by checking how often the problem occurs and how serious the deadlock is, how it and also how it affects the system. So if it happens like once in a very long time, they do not want to spend much money to resolve it. As resolve it, it would cost much more money than letting it happen. This approach is normally this ostrich algorithm approach is normally taken by Unix and Windows. So this method is reasonable. Like it is normally used when the uh, deadlocks occur very rarely, like once in a very long time. Secondly, when the cost of prevention is very high, the cost of resolving the problem is very high. So, and the third, the normally the deadlocks are handled by rebooting. If you can resolve the deadlock by rebooting, so there is no need to spend much money on it. There is also a relation between correctness and performance between the deadlock. uh, in other prevention methods, so what happens is when the CPU checks for the deadlock after a regular interval, it reduces the performance of the system, which is not the case with the deadlock ignorance algorithm, or I can say the ostrich algorithm. But the thing is, the correctness is vice versa, as there is a chance of losing data in ostrich algorithm, which is not the case with the other deadlock prevention methods. So let's move to spyware. So, what is spyware? It's a software that is installed on the computer anonymously, and it tracks the activities in the background. So, it is used for normally for advertising purposes, like companies hmm, track the users for their advertisement purposes. It can be used as a surveillance purpose, like the governments use it for tracking their citizens. In India, the government used Pegasus software to spy on their citizens. It came out as a breaking news. And it can also be used as a malicious sleeping cell. And like it is a kind of a soldier, and it is waiting for the instructions from his master to run malicious code on the victim's computer. So it's spread to various ways. One of the common ways is the Trojan horse, using like peer-to-peer file sharing apps like uTorrent, BitTorrent. Second is by through drive-by download, and it can be installed by with the executable files downloaded from the internet. Sometimes when the browser security settings are low, the spyware gets downloaded and installed automatically in the system. So what can the spyware do? So it can change the system settings, like changing browser's homepage, adding icons to the desktop, generating infinite pop-up ads, adding a new unwanted toolbars in the browsers. It can act as a keylogger as well as a it can track your location as well. There's much more spyware can do. One of the most recognized spywares in the world is Pegasus. It was created by an Israel NSO cyber firm as a surveillance software. It can be installed on iOS and Android as well. It gathers information by reading text, passwords, track location. It can access camera, even the microphone as well. It uses a zero-click engagement method to infect the device. It means it uses the network injection attacks on devices remotely. It can also carry out the chip level attacks. So what happens here is even after the factory reset, it can stay on the device, making it much more difficult for the normal antivirus to detect its presence. So it's one of the most recognized spyware. Next, we will talk about history of Android. Android was a software company which was created in 2003, which aimed to make the devices smarter by building softwares for it. So devices were introduced to Linux and then built upon them for wider use in the starting. So there were three languages which were used: Java, C++, and JavaScript. So then Java was acquired by Google in July 2005, and they focused with one language because they said that quality is much greater than quantity. Also, they were lacking behind the uh, project deadline, so they wanted to focus on just one language. So they worked on two projects which were named like Sooner and Dream. So these were devices to launch with Android. The Sooner was a QWERTY without touch phone with Android to release quickly in the market, while Dream was like a more important development with features such as touch panels, slide QWERTY, radio, compass for the Google Maps. The former project, the sooner was dropped because it took a lot of time, and by then the technology would have been out of date. They came out with Android 1.0 in November 2007. It was a touch screen with QWERTY keypad. So the name of the device was HTC Dream or TG Mobile. So then the development took place, and Android 1.5 came in early 2009, 1.6 in fall 2009, and now it's 2021. It's 2022, and the latest release was Android 12, which came out in around fall of 2021, and it's a huge progress from previous distribution. That's it from my side. Thank you so much, and I hope for the best. See ya.